So the first property we're going to discuss is the product of powers. What happens when you multiply two powers that have the same base? So for example, if I've got x cubed times x to the fifth, one way to think about this is to break it down into what the exponent actually means. So like if I have x cubed, what that really means is x times x times x. If I have x to the fifth, that means x times x times x times x times x. So this right here is coming from x cubed. These other 5x's are coming from x to the fifth. So really we're just multiplying a bunch of x's together here. So how do you suppose we're going to rewrite this or simplify this? Like how many x's total are we multiplying? 8 of them, right? So if I have x cubed times x to the fifth, that should equal x to the eighth, right? Because I'm multiplying 3 x's and then another 5 x's. So I've got a total of 8 of them. So if you could try to generalize what you do when you multiply two powers with the same base, how might you explain that? Yeah, so for those of you that didn't hear, what she said was if you're multiplying two powers, and they have the same base, so they're both like x, or they're both y, or 2, or whatever, then you add the exponents, right? Because we're basically adding the number of x's that we're multiplying here. So what happens when you multiply powers with like bases? You're going to add the exponents. So we can use that property to simplify a bunch of these different expressions. Okay, once you recognize that an exponent is just repeated multiplication, we can start to simplify something like 5 cubed times 5 squared, right? So 5 cubed times 5 squared, one way to think about this is that we're multiplying 3 fives and 2 fives. So how many total 5s are we multiplying? 5, right? So this would be 5 to the power of 3 plus 2, right? There's 3 5s and then an extra 2 5s. So that would be 5 to the fifth. Okay. That's something you could put in the calculator because there's no variables, but I'm going to stick with that for now just so you can see how it would play out if you did have variables. Number 2, we've got 4 negative 3's being multiplied times negative 2 3's being multiplied, so that's kind of weird. But we could still follow the same property. 4, what's 4 plus negative 2? 2. It's 2, right? It's the same thing as 4 minus 2. So my answer should be negative 3 squared. For number 3, we've got a to the negative 4th times a to the 4th. So if we're going to follow that pattern of adding the exponents when we're multiplying two powers with the same base, that would be a to the negative 4 plus 4. Well, what's negative 4 plus 4? 0. And that actually allows us to use another property, right? What's a to the 0th power? 1. Now, if your terms have coefficients, the way that you're going to handle that, like in number 4, is by multiplying the coefficients together and then multiply all your variables together sort of separately. Okay, the reason why we're allowed to do that is because multiplication is commutative, meaning we can sort of rearrange the order any way we want. So if all I'm doing is just multiplying like 3 times x times x times x times x times x times 4 times x times 9 more x's, I can change the order, right? 2 times 3 is the same as 3 times 2, so the order doesn't really matter here. So first, we're going to multiply the coefficients. What's 3 times 4? 12 times x to the power of, well, what's 5 plus 9? Yeah, that's 14. So that is the product of powers property, meaning if you multiply two powers that have the same base, you add the exponents together. That's the basic idea there. All right, so the next property is called the quotient of powers property. Okay, this is very similar. In fact, if you just think about it as an analogy, you'll probably know the answer to this question already. Okay, if when I multiply powers that have the same base, I add the exponents, then if I'm going to divide two powers that have the same base, what do you suspect we're going to do with the exponents? Subtract them. That's exactly right. Okay, so it's very intuitive here. So if I want to expand, now let me show you like why that actually works out. If I want to simplify something like x to the 5th divided by x cubed, what that really means is x times x times x. There's 5 x's in the numerator, 3 x's in the denominator, and then I can start to simplify this. What is x divided by x? If I just had a single x divided by itself. It's 1, right? Anything divided by itself is 1. So what I can do is reduce any sort of pair that I have here, or you might call it cancel out, right? I can cancel out an x, an x, an x, and how many x's am I left over with? 2. So I would have x squared, which is what you would get if you did 5 minus 3. You would get 2. Right? So what happens when you divide powers with like bases? Well, similar to the last property, you just subtract them. So you're going to subtract the exponents. You guys can't really see that, can you? All right, so when they're set up like 5 and 6, they're usually pretty easy. One thing to keep in mind is that you're not allowed to leave any negative exponents in your final answer. So that if you subtract and you do get a negative exponent, that's okay, but you're just not done yet. We'll see what happens when that comes up. So number 5 says x to the 12th divided by x to the 5th. We don't need to go through the whole process of expanding out and canceling, although you can do that. If you know the property, you know that when you're dividing terms that have the same base, you just subtract the exponents. So this would just be x to the power of whatever 12 minus 5 is, which is 7. So this is x to the 7th power. And number 6 is an example of where you end up with a negative exponent, right? This would be 3 to the power of 2 minus 5. Well, what's 2 minus 5? Negative 3. So this is 3 to the power of negative 3, which if that were positive, we'd be done. But you might notice like every time I'm asking these questions, there's a little part of the directions that say something like, in this case, write your answer using only positive exponents. Right? On your quiz, it said, make sure there's no negative exponents in your answer. So I need to rewrite this. This could have been a problem on your quiz, right? How do I rewrite 3 to the negative 3 using positive exponents? Yes, sir. Yeah, you flip it, right? 1 over 3 cubed. Now that's something, again, you could probably put in the calculator, but for now, we'll just leave it like that. Any questions about what to do when you end up with a negative exponent? All right, number 7. So we've got negative 2 to the 7th divided by negative 2 to the 5th. So that would be negative 2 to the power of 7 minus 5, which is what? 2. You could take that one step further, and that's fine. But for now, I want to sort of just focusing on the properties themselves. So that's good. Now, what would that equal, by the way? What is negative 2 squared? 4. Yeah, negative 2 times negative 2. Right. Okay, number 8. So just like when we looked at number 4 and we had two terms that had the same base but they had different coefficients, we multiply those coefficients. Here we're going to divide the coefficients. So what is 9 divided by 3? 3. So we have 3 times m to the power of 4 minus 7. So that's 3 times m to the negative 3. So we have to deal with that negative exponent. And we get 3 over m cubed. Okay. Here's the next property, the power of a power. What happens when you raise a power to another exponent? Okay. Now, before I actually tell you what to do, what do you think is going to happen? Like if I say, what is x cubed to the 4th? What do you suspect the answer will be? And it's okay to be wrong. That's very good. So, yeah, so we've got 4 groups of x cubed. In other words, this is x cubed times x cubed times x cubed times x cubed. So we already know how to deal with multiplying powers that have the same base. You just add up all the exponents, right? So this turns into a product power property. So 3 plus 3 plus 3 plus, there's 4 of them, right? So 4 times 3 is 12. So that is the property for raising a power to a power. Okay, you just multiply the powers together. So what happens when you raise a power to a power? You just multiply the exponents. Oh, there you go. Multiply the exponents. So if I have q to the 5th cubed, so to the 5th to the 3rd, that would be q to what power? 15th, exactly. Because 5 times 3. If I have a to the negative 4th squared, well, what's negative 4 times 2? Negative 8. So it'll be a to the negative 8, but we can't leave any negative exponents. So we're going to rewrite this as 1 over a to the 8th. Y'all with me? Yeah? Okay. Number 11, we've got negative 5 cubed squared. So we're raising a power to a power. So what's the final power going to be? Negative 5 to the 6th. Yeah. Three cubed to the negative 3rd power would be 3 to what power? Negative 9, which would be the same thing as 1 over 3 to the 9th. Now if I raise an entire term to a power, like 2x to the 4th, one way to think about this is that I'm multiplying 2x, like whatever's inside the parentheses, by itself 4 times. In other words, it's like 2x times 2x times 2x times 2x. So how many 2's are there? 4. So this is really like 2 to the 4th times, how many x's are there? 4. X to the 4th. So what I want you to notice here is that when you raise a product to a power that is equivalent to just raising each factor to that power. So 2 to the 4th, x to the 4th. You've got to raise both of those to that same power. So yeah, I guess I kind of got ahead of myself. 2 to the 4th times x to the 4th. By the way, what is 2 to the 4th? Let's simplify that. Yeah, just 16. So what happens when you raise a product to a power? So like if you've got something like 2x or just something more than just a single number or variable, it's kind of like using the distributive property, right? You're going to take this 4 and distribute it to each factor. So the way I want to word that is that we're going to distribute the exponent to each factor. Oh, I'm going to run out of space here. To each factor. And you raise that factor to that exponent. So there might be like another property that comes into play. We're going to see that in a couple of these. Okay. So number 13 has 4d to the 4th. So we're going to raise each of these to the 4th power. 4 to the 4th times d to the 4th. Okay? And I know we simplified it before, but let's just leave it like that for now. Okay? I just want you to focus on the property here. You can always throw that in your calculator. What's 4 to the 4th? Whatever that is. Now we've got a negative exponent. Okay, we'll take care of that in a second, but first let's do use the property. Okay, and we're going to raise negative 3 to the negative third and f to the negative third. So both of those terms, since they have negative exponents, when we rewrite them with positive exponents, they'll be underneath a 1. 1 over negative 3 cubed times f cubed. So this was an example of a problem where we're actually using two properties. We're using the power of a product property and the negative exponent property. There's a lot of properties in this unit. Exponents are kind of weird. Okay, number 15. We've got to raise both of these to the second power, right? 2 squared times x to the 5th squared. All right, now we've talked about, this is like the 4th property we've talked about so far, so I understand if you don't have them all straight yet, but let's see if you remember. What do I do with the exponents when I raise a power to a power? Like this x to the 5th squared, you multiply them, right? So this would actually be 2 squared times x to the 10th. Good. And yeah, 2 squared you could write as 4. I'm not going to be super picky about that because I want you focused on the properties. But yeah, if you have a calculator handy, you could type that out, or maybe you just know that 2 squared is 4. Number 16. We're going to distribute this power of 5. So we have a cubed to the 5th times b to the negative 4th to the 5th. This one we're actually going to use a total of 3 properties. First, we use the power of a product property to distribute that 5. Now we're going to raise powers to a power. So we use the power of power property. Just like in the last one, that means we're going to multiply the powers. So this will be a to the 15th times b to the negative 20th. And now for the final step, we got to get rid of that negative exponent. So can someone tell me what my final answer here is going to be? You're on the right track here, but we've got that a. Don't forget about the a piece of it. What do you think?
A to the 15th over b to the 20th.
You got it. Yep. Yeah. All right, so power of a quotient. This is basically the same thing as the one we just did, okay? Before we raised a product to a power and we distributed the exponent to both of them, that same thing is going to happen here. Whereas if you have a fraction written to some power, then you distribute that power to both the numerator and the denominator. Right? The reason for that is if I have 2 over x to the 4th, that means 2 over x times 2 over x times 2 over x times 2 over x. So you have 4 of them, right? So when I multiply all these fractions, what I get is 2 to the 4th over x to the 4th. So notice, just like with the last property, I'm just distributing this exponent. So if you ever have like either a term or just something inside of parentheses that's being raised to a power, you've got to distribute that power to each factor. So what happens when you raise a quotient to a power? Just like with the last one, really all you got to do is just distribute the exponent. All right, so number 17. We're going to raise the numerator and the denominator both to the power of 3. So this will equal a cubed over negative 10 cubed. So you've got to distribute it to every single factor. Even if you've got a product in either the numerator and the denominator, if you look at 18, you've got to make sure to raise both of these things to the 4th power. So this will be 3 to the 4th times d to the 4th over 2 to the 4th. So when you have parentheses, you've got to distribute that exponent. Now, what makes 19 a little tricky? Or what makes it a little bit different? It's got a negative exponent, which we'll deal with. We'll deal with that at the end. Okay? So I'll have the same thing with the last one. 2 to the negative 5th, x to the negative 5th, all over y to the negative 5th. But when I try to get rid of those negative exponents, write them as positive exponents, I'm just going to change their position in the fraction, either from numerator to denominator or vice versa. So my final answer should be y to the 5th over 2 to the 5th times x to the 5th. So it's almost like that whole fraction just flips. So let's review here. What was the first property? Let's see. We had product of powers. So if I have something like x to some power times x to some other power, what do I do with those powers? What do you mean combine? Add them together, right? Yeah. So x to the a plus b, right? So that is the product of powers property. And you don't have to know the properties by name. You just have to know what to do with them. So if I multiply two powers with the same base, I add the exponents. What happens if I divide two powers with the same base? You subtract them. Right? What happens if I raise a power to a power? What do I do with them? I multiply them. Good. So if I multiply, I add, divide, I subtract, power to a power, I multiply them. If I raise a product, like let's say I have xy to the power of a, what do I need to do with that exponent? Distribute it, right? So that would be x to the a times y to the a. Similarly, if I have a fraction and I raise that to a power, I just distribute it. It's essentially the same property. X to the a over y to the a. So those are the 5 properties from today. But we've got a little bit of extra space in this bubble. Why don't we throw in the properties from last time so we can have them all in one nice place? Like what's x to the first power? X. What's x to the 0th power? 1. X to the negative a power is 1 over x to the a. So these are 7 properties. Or no, I can't count. 8 properties. Wow, that's a lot. So now let's look at some of those more complicated problems. Okay, let's start with number 22. So I'm going to not try to do everything in one step. Instead, I'm just going to sort of use one property at a time so that we don't get lost. So number 22, I'm going to start with the quotient property. So ignore the x to the 4th for just a moment. What is x to the 9th divided by x cubed? Oh, no. What do you do when you divide your powers? Subtract the exponents, which is x to the 6th. So this would be x to the 6th times x to the 4th. Okay. So x to the 10th, yeah. That's it. Any questions about number 22? Number 23. First, let's simplify that numerator. What is a to the 5th times a to the 8th? A to the 13th. 8 plus, so you really got to pay attention to these properties, right? You get a to the 13th over a to the 4th. So when I'm dividing, what do I do with the exponents? Subtract them. Okay, so a to the 13th divided by a to the 4th is what? A to the what? 9th. Yep. All right, now we're going to get a little crazy here. Look at number 24. So I've got this huge fraction all raised to the 4th power. So in terms of like the order of operations here, you have a little bit of freedom. Okay, like we could simplify everything in the parentheses first and then raise each thing to the 4th power, or we could raise each thing to the 4th power first and then simplify. Doesn't really make a huge difference. I guess what I would recommend is trying to simplify the parentheses first. So 2 divided by 3 is just that. It's 2/3. Okay, so we got 2/3 times. Let's focus on the a's here. What's 4 minus negative 6? Positive 10. So, yeah, what we've got is 4 minus negative 6, which if I subtracted negative, right, that's the same thing as adding. And again, use your calculator for that kind of thing. Like if you know, don't be a hero. All right, so then we have, what's b to the negative 2nd divided by b cubed? It'd be b to the negative 5. All right, so now we have all this to the 4th power. I just think it's a little bit easier if you simplify what's inside the parentheses first. Now when we go to distribute this power of 4, it just might be a little easier, I think. So we've got 2 to the power of 4 divided by 3 to the power of 4 times a to the 10th to the power of 4 times b to the negative fifth to the power 4. I still don't like that negative exponent. We'll take care of that in just a moment. What's the property when you raise a power to a power? Multiply the powers. Yeah, so a to the 10th to the 4th is the same thing as a to the 40th, yeah, times b to the,
Wait, is that supposed to say 3 to the 4th or 3 to 4?
oh, yeah, wow, that's just me being sloppy. It should be 3 to the 4th.
I should.
Yeah, good catch. No, that's good. What did you say?
-20.
Negative 20, good. Okay, so now we're just going to kind of put everything all back together and back to one big fraction. So any of the, like if you, like since the a has a positive exponent, that's going to end up in the numerator. B to the negative 20th, to rewrite that as a positive exponent, needs to go in the denominator. So this will be 2 to the 4th times a to the 40th over 3 to the 4th times b to the 20th. Number 24 and number 25 are pretty hard. Don't get me wrong. Like, if you're like kind of stressing, like, oh, those are pretty tough. Those are like the hardest kinds of problems you're going to see. Now we come to 25. Look at this behemoth. Yuck. This is just like a mess. It's all right. We got this. All right. So in the last one, we sort of simplified what was inside of the parentheses first. For this one, I want to do the opposite just so you can kind of see the difference. It doesn't make a huge difference, but I want you to know that you're okay doing it either way. So first, I'm going to apply the power of 2 and the power of 4, and then I'm going to sort of combine these fractions together. So first, I need to distribute this power of 2 to each thing. Wait a minute, I've got a b to the 0th. What does that equal to? 1. So I'm just going to basically scratch that out. I don't really need that. So here we go. 3 squared times x to the 4th squared times y to the 5th squared over 4 squared times x squared squared. And we'll multiply all those powers on the next step. So now I'm going to do this other fraction over here. We've got 2 to the 4th times x to the 4th times y to the 4th over y to the 5th to the 4th. So we got a lot of stuff happening here. The next thing I'm going to do is start multiplying the powers of anywhere where I have a power to a power. I'm going to take care of that in the next step. I'm not going to try to simplify anything else yet, because I just want to really just use one property at a time so that I don't get lost. All right, so we've got 3 squared times, what's x to the 4th squared? Be x to the 8th, good. So x to the 8th, y to the 10th, all over 4 squared times x to the 4th times 2 to the 4th, x to the 16th, y to the 4th, all over y to the 20th. At this point, I think I'm ready to combine the fractions together, right? Which I'm just multiplying. So if there's any instance where I'm multiplying powers with the same base, like for instance, you know, like y to the 10th times y to the 4th, what do we do with those powers? Add them, right? So that'd be y to the 14th on top, right? Okay, so we've got 3 squared times x to the Well, what's 8 plus 16? 24. Okay, so x to the 24th. We already talked about y. That'll be 14. Y to the 14th. Over. Move this up a little bit. 4 squared. X to the 4th. Y to the 20th. Whew. Oh, wait, we missed one. Oh, what about the 2? Times 2 to the 4th. Okay, on these really big, long ones, it's easy to lose track of stuff, for sure. All right, last step. We have to subtract some of this stuff. I think what we might do here is maybe we should simplify some of these numbers just to kind of clean this up a little bit. What's 3 squared? I'm going to put this in the calculator. So we've got 3 squared times 2 to the 4th is 144. So that's going to be that coefficient in the numerator. So 144, x to the 24th, y to the 14th, over, what's 4 squared? 16, x to the 4th, y to the 20th. So, now, I said before, I'm not going to be too picky about like raising the numbers to powers, but I think with a problem this big, it sort of helps us to clean it up a little bit. So that fraction we're going to leave alone. We can now divide these terms. What do we do with the exponents when we divide? Subtract them. So this will be 144 over 16 times x to the 20th times y to the what? What's 14 minus 20? Yeah, good. Negative 6. Unfortunately, we've got a negative exponent, so we've got to deal with that. Yeah. So just stick it on the denominator, right? So 144, x to the 20th over 16, y to the 6th. And that is finally our final answer. So that's a pretty beastly problem, yeah?